for example, you have a piece of cake and you are required to distribute it among your friends. So you would be cutting it into several pieces, right now.
Yes.
So say, for example, you have a pie, for example, or a cake, you cut it into two pieces. Now, if someone were to ask you to mathematically represent this, someone asks you to represent it in numbers, so you would say that this whole piece of pie, I can represent it. I would say that this is whole and this is, I can represent it as one. Now,
Yeah.
if I were to cut it into two pieces, I would say that now one has been divided into two parts, like 1/2 and 1/2. It has been halved. Okay, now.
Okay.
Or say, for example, if I were to say that this is this is a purple color and this over here is a red color. Now, if I were to ask you, look at their size, look at the size of purple color and the red color which I have drawn over here, and I ask you to find the half of purple. Say that this is purple rod and this is red rod. Now I ask you to find out the half of this purple rod. The half of purple rod will be simply this red rod. It looks as if it is almost half the size of the purple rod, isn't it?
Yes.
Right. Now further, if I were to draw this yellow color rod over here, this yellow color rod over here, and now I'm asking you to find the half of this red rod. What would you say? Find the half of this red rod. What would you say? Yes, that would be simply yellow rod now.
Yes.
Getting it or not?
No, I did not heard. What did you say?
See, I basically, we have got three rods: purple rod, red rod, and yellow rod.
Okay.
If I were to find out what would be the half of the purple rod, what would be half of this purple rod? So thereby this would be this red rod.
Yes.
Getting this or not? Or
Yes.
if I were to ask you what would be the half of red rod, that would be this yellow rod,
Yes.
isn't it?
Yes.
So basically the thing over here is that we can use fractions in our daily life. We have got different uses of fractions in our life. Just like you had this example of a pie where it can be divided into different pieces and each pieces can be represented using a number. For example, it is divided into two pieces, so thereby it can be shown using number 1/2 and 1/2. Further, let's say that this were to be divided into four pieces. So now as a whole, it was one. As a whole, this was one, but now it has been divided into four pieces. So thereby we say that each pieces can be represented as 1/4, 1/4, 1/4, and 1/4. Getting it, was? Now, logically speaking, that if you were to add all these fractions, it should be equal to 1. If you were to add 1/4, 1/4, 1/4, and 1/4, it should be equal to 1 now.
Yes.
So 1/4 plus 1/4 plus 1/4 plus 1/4. What is the LCM?
4, 1 whole.
No, LCM is going to be 4 now. Lowest common multiple is going to be 4. And above also, it is going to be 1 plus 1 plus 1 plus 1. That is simply 4. So the number is 1. Now 4 and 4 cancel. You are left with 1.
Huh.
So didn't you got back 1 upon adding all the fractions? Or you were to add this half and half, you would be getting the whole piece of this cake.
Yes.
They are apart from these also, there are different concepts We have learned about fraction, the different examples of fraction. Okay, now
Yes.
let us learn about different types of fraction which we have. There are different types of fractions. Do tell me what types of fraction you have studied in your school.
Proper fraction, improper fractions,
Very good. Then
uh,
mixed fraction also must be there, right? So let us learn about different types of functions. I mean fractions. Okay, now. So first of all, learn about proper fractions. What are proper fractions? So say for example, you have the following numbers. For example, you have a number like this. Let's say 1 upon 4, 1 upon 2. 1 minute. You have numbers like 1 upon 4, or you have number like 1 upon 2, 3 upon 8, 7 upon 9, 11 upon 13. Also, there's one more important thing you need to know. Like whatever type of fractions which we have, like 1 upon 3, 9 upon 11, minus 11 upon 16. In this, the upper number is called as numerator. What do we call this as?
numerator.
And the number that is below the
Is
stack, very good, that is denominator. Now in those cases, now in such fractions, if the numerator is lesser than the denominator, they are called as proper fraction. 1 is smaller than 4, 3 is smaller than 8, 1 is smaller than 2, right? Now so all these are examples of proper fraction where numerator is smaller than denominator. Hope you are getting it. Can you quote some more examples of proper fraction?
2 upon 3.
2 upon 3, good. And give some more examples.
3 upon 5.
3 upon 5 and
8 upon 12.
8 upon 12.
9 upon 11.
11 can also be taken. Good. Okay, now. So these are the different types of, these are examples of proper fraction which we have. Then what about improper fraction?
I know.
Yep. Explain it.
If the denominator is less than the numerator, that means it's an improper fraction.
Exactly. Right now. So we have examples like, give some examples.
5 upon 3.
Very good.
12.
9 upon 11, is that an improper fraction?
No.
No. So thereby it should be 11 upon 9. Okay. And
8.
8 upon
8 upon 7.
7. Very good. So these are the examples of improper fraction where you have got denominator is lesser than numerator. Numerator is bigger in all these cases. These are the such examples. Okay. Then later on you have got mixed fractions also. Let's us learn about a mixed fraction. What is a mixed fraction? So mixed fraction by name itself, it says that it will be a combination of a natural number and a fraction. Say for example, you have a number like this, 3, 1 upon 5. So here 3 is a natural number, no?
Yeah.
This is a natural number, and 1 upon 5, that is a fraction. So we say that mixed fraction is it's a combination of natural number and fraction. Hope you are getting it right now.
Okay.
Okay, have you learned about like fractions and unlike fractions?
No.
Not yet. Okay, let's learn about this also. Like fractions, and on another hand, you have what unlike fractions. Okay, what can you say about the following fractions which I'm going to write over here, like 1 upon 2, 3 upon 2, 7 upon 2, 9 upon 2, or 5 upon 2? Or what would you say about these following fractions, like you have 1 upon 2, 1 upon 3, 7 upon 9, 8 upon 6, or 5 upon 3? What did you observe between these two sets of fractions, was? In the
The
first
like
one,
sum of the denominators are same.
all of denominators are same actually. This is also 2. All denominators are same. While in this case, what we observe, that denominators are different, isn't it?
Yeah, not the same.
Good. Denominators are different. So that is like fraction and unlike fraction. Okay, now
Okay.
hope you are getting it. Now you know that addition of these fractions are very simple. Let's say if I were to ask you to add all of them. I ask you to add all of them. Addition of these fractions, it is very simple. What you need to do? Simply take a dash and write the denominator. Denominator is 2, so simply write it. And whatever numbers are there in numerator, simply add them. So add 1, this 3 over here, this is 3. Add 1, 3, 7, 9, and 5. So that is 1 plus 3 plus 7 plus 9 plus 5. What would be the sum of this?
Uh,
Yes.
26.
How can it be 26? 1 plus 3 is 4, 4 plus 7 is 11, 11 plus 9 is 20, 20 plus 5 is 25, no? Getting it, Moaz? 25
Okay.
upon 2. So their addition is very simple. While if you were to talk about the addition in the case of unlike fractions, have you learned about this in your school?
We have to
No.
find the same denominator.
No, you don't have to find the same denominator, because there is no same denominator in this one. So how can you find same denominator? It's a little lengthy method, since we need to factorize the denominator first and then simplify it.
Yeah.
Say for example, you have to add, let's take a smaller example. Say for example, you have to add 1 upon 2 and 1 upon 3. You want to add them. Okay, now. So in order to add them, first of all, you need to find the lowest common multiple of 2 and 3. Was did you studied about lowest common multiplication in your school? In
No.
short, it is LCM. Not yet.
No.
Okay, you have been going to school regularly now. You haven't skipped any classes.
I did not went to school for 2 weeks.
Okay, were you
Because I
sick?
was yeah, and then
Oh,
in March I was absent for 2 days.
okay, okay, no worries. Okay, let us quickly learn about that also. Okay, no? See, if I were not to write two numbers, like take the same number 2 and 3, what are the multiples of 2? Quickly tell me.
2, 4, 6, 8, 10, 12, 14, 16, 18, 20.
Like this. Good. What about 3?
3, 6, 9, 12, 15, 18, 21, 24.
And so on and on. Right now, it can go up to infinity. There's no end to it. Okay, now if I were to ask you, which is the which are the common multiples between them?
6
6.
and 18.
Apart from 6, there's 12 also, no? After 6, you have 12. Then you
18.
have 18. Okay, like this, you'll be having many more multiples. But if I were to ask you about the lowest common multiple, then what is the answer?
6.
That would be 6 for this one, no? Lowest common multiple, in short, it is written as LCM. Okay, hope you have understood what is LCM. Okay. So
Okay.
now in this case, first of all, you need to find the LCM of 2 and 3. Step 1, you have to find LCM of 2 and 3. So 2 and 3, the LCM is going to be 6. Moments ago, we have found that, no?
Yes.
That of 2 and 3 is 6. Okay. So simply, what you're going to do, now you need to multiply 1 upon 2 and 1 upon 3, 1 upon 2 and 1 upon 3 with such a number so that their denominator becomes equal.
Hmm.
Let us understand what I'm trying to say. 1 upon 2 and 1 upon 3. I need to multiply both of them with such a number so that their denominator becomes equal to 6. Like it should be equal. Like what should I do? Because I have know that the LCM of 2 and 3 is going to be 6. So I'm going to make their denominator as 6.
Hmm.
Oh. So you tell me 2 should be multiplied with which number so that it becomes 6?
Times 3.
3 now? Okay. So you will be multiplying the numerator also with 3. Okay, no? Because you can't leave it empty over here. Right? So 1 3s are going to be 3. 3 upon 6. Okay.
Hmm.
Then what about this over here? Here also, in order to make the denominator 6, with which number 3 should be multiplied?
2.
2. So numerator will also be multiplied with 2. So the number is 2 upon 6. Is it clear to you so far or not?
Yes.
So now the fraction have become 3 upon 6 and 2 upon 6. Now, are they like fractions or are they unlike fractions now?
I
Yeah,
mean,
like fractions. What did we learn about addition of like fractions? We simply
multiply
add the numerators now,
at the numerators.
and the denominator is going to be same. So the answer is going to be yes.
Uh,
Add the numerator of
5
these two
upon.
fractions. 5 upon 6. Okay, did you understood that?
Yes.
Okay, so do a question and then we'll be moving. Question on addition of unlike fraction. You have a question as follows. The first question, let's say you have a number 1 upon 5 added to, let's say you have 4 upon 3. Both of them are unlike fraction. You have to add them.
Hmm.
What is the first step you are going to do? Tell me.
Find the same.
LCM
Find the,
of 5 and 3. Okay, find it out.
it's 15.
15. Very good. So just write 15 in the denominator and then
It's 5 upon 15.
not 5 upon 15. There was one more step before doing that now. You have to convert the denominator to 15 now. Like,
Oh.
hmm,
3 times 5 equals 15.
very good. So here, okay, do it on your copy. Then let me know the answer. By the way, this is 1 upon 5 actually. This one over here is.
This will be 5, 5. We'll have to do both of them?
Yeah, you have to do both of them and then they will be added now. Just like we did for this one now. Once we equated the denominator, so then these two numbers were added. Do the same thing for them.
Done. Wait,
Done?
done.
Okay, what is the answer?
Answer is 8 upon 5.
No, that isn't correct. That
No,
isn't
for
correct.
for both of those answers combined together equals 8 upon 8. For the 1 upon 5 multiplied by 3 over by 3 equals 3 by 15.
Okay, good. Then
4 by 3 times 5 by 5 equals 5 by 15.
4 times 5 equals to 20 now. 4 times 5 is going to be 20 now, Moaz. It's 20 upon 15. Okay. Now you have got like fraction 3 upon 15 and 20 upon 15. Now tell me what is the final answer. Note that this is now a like fraction. And you can
23.
simply, that is
Improper.
23 upon 15. Not asking about improper. I'm saying that this is a like fraction. Their
Yeah.
denominators are same, so simply you can add their numerator. It becomes 23 upon 15. Okay. So hope you have understood that. Is that clear to you?
Yeah, but don't we have to simplify it?
Why this need to simplify this number? 23 upon 15, they are not divisible with each other. There's no need to simplify it any further.
Oh.
If you were to have a number like 9 upon 18, then you have to simplify it because 9 cancels 18 and it becomes 1 upon 2. Getting what I'm trying to say? Okay. Okay. Then we have one more type of fractions. We have got equivalent fraction also. Did you learn about it in the school?
Yeah.
Good. Equivalent fractions. Can you explain this? What is equivalent fraction?
Equivalent fractions. What to say?
Yeah. See, I'm writing some numbers for you. Meanwhile, if you recall it, then you can also answer. Okay, now try recalling it while I'm writing few numbers.
Like equivalent fractions is like your fraction, but you still double it. Like double it. 1 upon 2 plus 1 upon 2 equals 2 upon 4.
Okay, you're a little bit close to explaining it. See, you have got two, like whenever you will be having two or more than two fractions, and if they get the same result after simplification, like you tell me 2 upon 4 after simplification will be what? It will be
1 upon 2.
what about 3 upon 6?
1 upon 2.
And
1 upon 2.
this one?
1 upon 2.
1 upon 2. So after simplification, all of them are equal, no?
Yes.
Right now, so such fractions are called as equivalent fractions. Such fractions are called as equivalent fractions. Huh? So, for example, you have a question. Let's say the question says that you need to find some equivalent fraction. For example, I am asking you to write some equivalent fraction for 3 upon 7. Question says write 3 equivalent fraction for this given number. What you can do? First of all, you're going to multiply the numerator and denominator with 1, both of them. So that is 3 upon 7. Then you're going to multiply both of them with 2. So that would be how much? Quickly. 6 upon 14 now.
Yes.
Right. Next, you will multiply both of them with 3 upon 3. So thereby
3
that will
upon.
become 9 upon 21.
Yes.
Then again you are going to multiply them with 4 upon 4. So you are multiplying them with consecutive natural numbers. So you have 12 upon 28. Now, are all of them same when we simplify them? After
Yes.
simplification, 6 upon 14 will become 3 upon 7. This will also become 3 upon 7. This also becomes 3 upon 7. You know how to simplify the fractions now?
No.
No. Okay, okay. See, for example, there's a number 6 upon 14. Okay. Now, you can write 6 like this, now 2 times 3. Can't you write like this? And how can you write 14? You answer
2
this to me.
times
2 times 7. Okay, now in the numerator and denominator, there are two numbers which are same.
Yes.
And that is 2 now. So you can cancel 2 and 2. What are you left with?
3 and 7.
So basically 3 upon 7. So that's how you simplify the numbers. That's one of the easiest way. Oh.
Huh.
Okay, do the same exercise for 9 upon 21. You do
9
this
upon.
one. Yes.
Done.
Done. Okay. So how did you write 9? How did you wrote this number?
I wrote 3 times 3.
Good. Then 21 is
3 times 7.
okay. Which two numbers are getting cancelled?
3.
This 3 and this 3. So you are again left with 3 upon 7. Okay now. So we are having same numbers. The simplification is same. So hope you are guys are getting it. Okay. So will you be able to do one question? Yeah.
Okay.
Okay. So I'm giving you a question. Write 3 equivalent fractions for this number. The number is 3 upon 5.
Done.
Done. Good. What is the answer?
6 upon 10, 9 upon 15, 12 upon 20.
12 upon 20.
20.
Very good. Okay, if I were to ask you to find 2 more equivalent fraction,
It will be 15 upon 25,
Hmm.
18 upon 30.
18 upon 30. Very good. So now you have learned about equivalent fractions. This is how it is done. Okay, now.
Hmm.
Next, we are so far. By the way, let me quickly summarize whatever the things we have learned. We did learn about fraction. What is fraction? We learned about proper and improper fraction, and then mixed fraction also. Like fraction, then unlike fraction. Right now, and also we learned about how addition is done for like and unlike fractions, and what is equivalent fraction, and how do you find the simplified fraction, and how to find equivalent fractions also. Now we are going to learn about ascending and descending order in the case of fractions, how ascending and how fractions are um, arranged in the ascending and descending order. So let's learn about ascending and descending order of fractions. You understand about terms like ascending and descending, right? Ascending means in an increasing order from the smallest to largest, but descending means from decreasing order from biggest to smallest. Huh?
Okay.
So for example, if you were to talk about ascending, right now we are only talking about ascending order of fractions. Say ascending order of fractions will be kind of like this. For example, you have the number of fraction like 1 upon 2. You have fraction like 1 upon 2. Then you have 1 upon 2. Then you have 3 upon 4. So here, for example, if you were to have one more fraction, like let's say 1 upon 3, there are 3 fractions given over here: 1 upon 2, 3 upon 4, and 1 upon 3. Now we are asked to arrange them in an ascending order. We are asked to arrange them in an ascending order. So the ascending order is going to be like this. Now look out for the fraction. Look out the fraction for the fraction over here, which has got the smallest, the biggest one over here, the biggest denominator. Or for example, if you were to have some other examples, let's not take this one. Take some other examples. We can take the fractions like this: 17 upon 13. Let's say you have 11 upon 13, or 15 upon 13, or you were to have a 7 upon 13, let's say, and we are required to arrange them in an ascending order. Question says arrange in ascending order. Let us learn how we are going to do. In this, simply do one thing: just compare the numerators. Compare the numerators: 7, 15, 11, and 17. You will be comparing the numerator. Denominator are same now here,
Yeah.
right now. So compare the numerators, and the
Wait,
one that is smaller here.
if the denominators are different, do we have to check the denominators and numerators?
See, whenever you have a like fraction in which all the denominators are same, and you are asked to arrange them in ascending order, so first of all, look at the numerators and write all the numerators. I mean to say that start writing from that fraction, start arranging it in ascending order from that fraction which has got the smallest numerator. So first you will be writing 7 upon 13. After this, you would be writing 11 upon 13, then 15 upon 13, and then finally 17 upon 13. So in this, what we would find that this is the smallest and this one is the biggest. I will be back in a minute. There's someone on the door. Yes, I'm back. Yes, Moaz. So 7 upon 13 would be the smallest number, and 17 upon 13 is the largest number. That is the biggest fraction over here. Is that clear to you or not?
Yes.
Okay, I'm giving you a question. Arrange them in the ascending order.
I write it in my book.
Yeah. Right now we are ordering fractions with same denominator. Okay, no?
Done.
Okay, which is the first one?
5, 11, 5.
And then
7 by 11.
next
12 by 11.
and
13 by 11. And 19 by 11.
okay, and if you were asked to write them in descending order, you will simply start from where?
19, 11. 13 by 11. 12 by 11. 7 by 11. And 5 by 11.
5 by 11. As simple as that, right now. So that's how
Yes.
you arrange them in the ascending and descending order, only when the denominators are same. Okay. Now say that if the numerators were to be same, for example, you have 3 upon 7, you have 3 upon 8, you have 3 upon 5, or you have 3 upon 4. In this case, say that, let me write the case. Case is ordering the fraction with same numerator. So in this case, what you are going to do? Here, clearly numerator is 3 in all the fractions. So then you will be comparing the denominator. So upon comparing the denominator, you find out that they are in this order. Right now? So corresponding to the fraction to which these denominators belong, you will arrange them in this order. There will be 3 upon 4, then it would be 3 upon 5 and 3 upon 7, and then which one we left? 4, 5, 7, and 8 now. 4, 5, 7, 3.7, and then 3 upon 8. Getting it was or not? Okay, if you have got it, then solve one question. You have, let's say that you have 8 upon 9, 8 upon 16, 8 upon 13, or 8 upon 11. Arrange them in the ascending order. After having learned this, we are going to learn about ordering fractions with different numerators and denominators. Yes, what is the answer?
First one is 8 upon 9.
Okay, then
8 upon 16, 8 upon 11, and then 8 upon 13,
13.
8 upon 16.
Very good. So that's how you do it. And this is in ascending order. Descending order will also be very easy. How do you arrange them in the descending order?
Opposite way.
Opposite simply, right? In descending, you simply do the opposite. That will start from 8 upon 16 and continue it in this manner. Now let us understand about how do we order the fractions which have got different numerators and denominators. Okay, no? Say for example, you have fractions like 2 upon 5, or you have 4 upon 6, then you have 3 upon 5, and then 1 upon 3. Clearly, all of them have got different numerators and different denominators. Huh? So we can't use the previous methods in this. So what method are we going to use in this example? Any idea? Yes, Moaz? Okay. What are the numbers in denominator?
5, 6, 5, 3.
We take them only one time. If they are repeated, do not take them. Okay, now just take 5, 6, and 3. Okay.
Okay.
5, 6, and 3. 5 is repeated, so we are taking it only one time. So numbers in denominator are 5, 6, and 3. So thereby, you are going to find their LCM. Just like you did it in the case of this one over here. In the case of unlike fractions, now you used to find its LCM. Remember?
Yes.
Same procedure has to be applied in this case also. So do tell me what would be the LCM of 5, 6, and 3. 5, 6, and 3. 5 ones are 5. Yep. Yes, Mouse. You tell me which is going to be the lowest common multiple. We have to write some more numbers over here. After 25, it is 30 over here. Okay, no? And after 24, this is 30. Let me rewrite it. That is going to be 30, isn't it?
Yes.
Yeah. Because for 3, you have to take 3 times 10, that is 30. So 30 is the lowest common multiple that they have. Very good. So you have got 30. Okay, now. Now what we're going to do? Now we are going to find the equivalent fractions. You have the fractions 2 upon 5. You have 4 upon 6, 3 upon 5, and 1 upon 3, right? So remember what steps we were doing in the previous? We are required to make all the denominators as 30. Keep that thing in mind. So you would be multiplying it with 6 upon 6, that is 12 upon 30. Doing the same thing with this one, but with a different number. So you find it out. Once we find out the equivalent fraction, then it will become easy. Yeah. Just quickly.
Uh,
6 has to be multiplied with which number in order to get 30? Just think of this now. Read the table of 6. 6 5s are 30 now. You're simply multiplying it with 6 5s now.
Five.
Okay, then numerator also has to be multiplied with the same number. So thereby that becomes 20 upon 30. Okay, remaining 2 you have to do it. Quickly do this.
3. Six. So,
Boss, you have to follow the same procedure as we were following previously. For this case, now remember this case which we discussed moments ago?
yes.
Like how we were required to add unlike fractions, how addition
Yes.
of unlike fraction was done. Keep that thing in mind. Our basic goal is to make all the denominators equal. See, if you keep this thing in mind, then it will become very easy for you. Then you will not get confused on this. See, our main aim is to make all the denominators equal. Because once the denominator is equal, so then you will compare the numerator. So it will become easy. So that's what we are doing over here. So 5 should be multiplied with which number so that in the denominator you will be getting 30. 5 ones are 5, 5 twos are 10, 5 threes are 15. Have you memorized tables up to 10 or up to 20 or not? Have you
Yeah.
memorized tables? How many? How much tables you have memorized?
I know
Was
up to 11.
up to 11. Okay. So 5, 6 are going to be 30 now. 3, 6. We're going to write 18 over here. Are you actually getting it or not? Or just nodding yes to me? See, if you're not getting any concept, be frank and just tell me, sir, I'm not getting it. Okay, now because you have to understood it. Then only you will be able to solve question. Okay. Okay, then 1 upon 3. The last one you will be answering. I will not be explaining this one. Answer this one at least.
So 3 times 10 equals 30. So the denominator will be 10.
Okay, and
the numerator will also be 10. So it's 10 upon 30.
very good. So now you have the following fractions. You have 12 upon 30, 20 upon 30, 18 upon 30, and then 10 upon 30. Now finally we can arrange them in the ascending order. Right now, just look at the numerator. Which one has got the smallest numerator?
10 upon 30.
10 upon 30. So write this one first. Next.
12 upon 30.
Okay, next.
18 upon 30.
And then
20 upon 30.
20 upon 30. So now we have arranged it in the ascending order. So that's how it is done. Getting it now?
Yes.
Okay, so hope you have got it. Okay, now there are a few other things also left to be discussed in this. Like we haven't discussed about in the case of some other cases are also, some other questions are also left to be discussed. Okay, now. So in the next